Okay, so our topic is composite trapezoidal rule. This is an improved trapezoidal rule. The only difference here, class, is that the range, our range AB, is divided into number of small intervals, unlike in the trapezoidal rule, where the formula is really based from the area of a trapezoid. Now, if you look here from our figure, in our figure here, this range, which is A and B, okay, so in between them there are intervals, small intervals. As you can see here, they are spaced with H. If you could recall, H, class, is the difference between H1 and X0, X sub 2 and X sub 1, X sub 3 and X sub 2, so on and so forth. And if you can see, the value of the H here is equal. Okay, so equal spaces or equal width. Now, how are you going to solve this kind of composite trapezoidal rule or using this method? So we'll be able to integrate using this method by the usage of this formula. The h over 2 times the functions. Take note, take notice of the values of the functions. If you compare with the formula of the trapezoidal rule, in trapezoidal rule, we only use the f sub 0 and the f sub 1, which corresponds to f sub a and f sub b, right? In this case, this f sub 0, this f sub 0 here is solved by substituting a to our function. If you recall here, this a represents your f sub 0, while the f sub n is by substituting b to your function. You follow? How about this f sub 1? So this f sub 1 can be solved by, as you can see here, so a plus h. Okay, so you'll be able to solve for x sub 1. So whatever the value of your a, just add the value of your h and substitute that to your function and you'll get the f sub 1. The same with f sub 2. In order for us to solve for the value of x sub 2, so we simply get the value of a plus 2h. It's because between the a and the x sub 2, we have 2h, so a plus 2h. Okay, so the same with f sub 3, so you'll have to add 3h from a. Okay, so it depends kung ilan yung n natin. Okay, again, the f sub n there refers to your f sub b. Okay, so how are we going to solve for h, for the value of the h? Okay, so the value of h will be b minus a all over n. Okay, your n there corresponds to your number of stripes. Now, if we go back to our figure, the number of stripes there is this one, this one. If you notice, 'di ba, sa mga ano natin, sa mga damit, 'di ba? Stripes refers to the lines. So, how many lines are there? So, in this case, there are 6. So, that means your n is 6. So, b minus a divided by 6, that would be the number of your, or the value of your h. Okay, so again, that will be the formula for the composite trapezoidal rule. Now, for us to understand this clearly, we'll have an example here. By the way, like I have said, the range A and B is divided into n stripes with equal h. Okay, now let us have an example. Let us evaluate the integral of sine x from 0 to pi by dividing into 4 stripes. Now, let us first analyze our problem. What are the given from this statement? So, the given is obviously First is the function, which is the sine x, as well as the number of stripes, which is 4, and the value of our lower boundary, which is a, which is 0, and the upper boundary, which is the b, which is equal to our pi. Now, how are we going to solve for the integral of such function? So using the numerical integration and by the usage of the composite trapezoidal rule, we will be using the composite class is because it's the one that is suitable here. Why? It's because there is a number of stripes. Okay, the interval is divided into number of stripes. We cannot use the normal trapezoidal rule. Is because in the normal trapezoidal rule, only 2 points are taken, which is the f sub 0 and the f sub 1, or the f sub a and the f sub b. So in this case, there are 4 stripes, so therefore we need to use the composite trapezoidal rule, which if we recall, the formula is this. Okay, so based from our given, okay, the value of the h based from our formula b minus a all over n. So substituting, b is pi and a is 0 all over the n, which is 4. So our h will become pi over 4. Now how about for the f sub 0? Like I have said earlier, f sub 0 refers to your what? Your function or the value of your function if you substitute your value of a there. Ano ba yung value ng a natin? The value of a is 0. So substitute 0 from our function. What's our function again? The function is sine x. So substituting sine 0, so that would be 0. So the value of your f sub 0 is 0. Now how about for the f sub 1? F sub 1 is solved by adding h to your a, or substituting a plus h to your function. So your h is pi over 4 while your a is 0. So therefore, we'll get the value of the function at pi over 4. So that would be sine pi over 4. So using your calculator, that would be 0.707106781. Okay, that's for f sub 1. Now, how about for f sub 2? For f sub 2 class, the f sub 2 is the same. From a, you will add 2h. Okay? So substituting, we'll have that value. So we'll have 2 pi over 4, or that is pi over 2. So sine pi over 2 or 2 pi over 4, that will be 1. Okay? Now, how about for f sub 3? The same. We will add 3h from our a. So the function will be 3 pi over 4, and that would be sine 3 pi over 4, and the value is that. Okay, so you can check that with your calculator. Now, how about for our f sub 4? For our f sub 4, the value is the same. You add 4h to your a, so that would be a plus 4 pi over 4, or simply pi. Okay, so substitute pi to our function, that would be sine pi, or that is equal to 0. Okay, now, how about for the f5? Do we have f5? Take note that our n is how much again? N is 4. Now, do we have f5? No, there is no f5. Why? Why don't we have f5? It's because, like I have said, n minus 1 is 3. It's because our n is 4, right? So, minus 1, 3. So, that means na hanggang f3 lang yung dito sa may parenthesis, while the fn already is our f4. That's why, etong 0 na to, this f4 here, is already our fn. So, hanggang dun lang yung calculation natin. Nakuha? So, therefore, way back from